Now, it's actually rather difficult to get too excited about plotting in MATLAB because at some point you're just like, if I really need to know this, I'll look it up later. But I just want to show you a couple of examples of things you can do. So I'm using the subplot so that you can see kind of the different ways subplot. So first of all, you can see subplot, and also you can kind of see all these different options at the same time. So I've just got some random data that I threw in here. So subplot 2, 2 means it's going to be a 2 by 2 of subplots. Ooh, come back. It's going to be a 2 by 2 of subplots. I'm going to plot in the first part, then the second part of the first row, then the second row, and then the next part of the second row. Because remember, it fills in the plots by rows, just like you would fill in a matrix by rows. So just to kind of show you what these are going to look like, you've got a bar graph that does precisely what it sounds like it does. You can do multiple bar graphs at the same time. You can do little 3D bar graphs, just to give you an idea. You can do pie charts. So really anything that you can do in Excel, you can do in MATLAB. Other thing you can do is histograms. Maybe you remember what a histogram does, but basically what a histogram is going to do is it's going to take data and it's going to sort it. So now it's going to pop up with the histogram. But what it's going to do is it's going to sort it, and it's going to give you like a quantity per bin. And by bin, it's going to kind of divide your data out into 10, by default, 10 sections of data. So if I had data actually starting at 0 and some more data here, looks like 10. So you can see what it's going to do is it's giving me a count of how many values are in each bin. So this bin goes from 0 to 10, and this one is from, 10 to 20. So there are like 2 numbers between 0 and 10. Maybe not. Well, there we go. Yeah, 2 numbers between 0 and 10, but there are no numbers between 10 and 20. So if I sort it, I can see that. Okay, there's no numbers between 10 and 20, and basically it just gives me a count. So there's 1, 2, 3 80s. So I see 3 80s, and there's actually 3 90s. So what a histogram does is it counts the number of elements that you have that would fall into each category. And this can be a very kind of useful thing if you're looking at statistics for something in particular. So you can change the number of bins, the number of sections that it sorts it in. So I could say histogram X5. So say I only wanted to separate into 5 bins. And so there we go. So basically I have 2 in the first section, 4 in the next section, 3 in the next, 2 in the next, and 6 in the next. So this allows us to see a distribution. Now what's cool about this, that's not what's cool about this. So what's cool about this is if I'm looking at random numbers, so let's do a histogram with random numbers. So I want to make sure my numbers that I'm generating are actually random. So I want to generate some, so 1 by 50 random numbers. Okay, so I've generated some random numbers, and if I plot them, I mean, I can see what they look like, but they're kind of all over the place, so I don't really know if I've got an even distribution of things on one side or the other. Now, if I do a histogram, oh, not that. If I do If I do a histogram, now I can see that it kind of shows me how many of each that I have in each category. So I've got kind of more on the low side, I've got a whole bunch kind of in the middle, and then some here. So let's actually generate more. So I'm going to generate like 100 random numbers. Okay, and now I'm going to, as I generate, so I'm not changing it, but you can see how the distribution of those random numbers is. So this, I randomly generated 100 numbers, and I actually ended up with a whole bunch that were in the 0 to like 0.1 stage. This is really, really interesting. So this kind of helps me see that random numbers, you know, even though I generate 100, they don't really evenly distribute. That said, the more of these that I do, then I'm going to see that the numbers, those are going to come a lot more close. So if I do more, so now I'm doing what, 10,000 random numbers? So as I do 10,000 random numbers, then their distributions becomes pretty even because I have that many more trials. If I go back down to only having 10 random numbers, they're really all over the place. And again, that's what 100 look like, 1,000, no, not that, 1,000, 10,000, 100,000, a million random numbers, and now that's really, really, really settled. You may or may not know you can put an N here, and that gives you a normal distribution, and that's your bell curve. So that allows you to see. So if you want to increase the number of bins, you can actually get something that looks even more like a bell curve. So that's 1,000,000. And it really does look like a good little bell curve there. So one thing that the histogram does let you do is it lets you look at the quantities of data and how the quantities of data work together in a way that maybe just plotting them. And again, if I just, except I've been plotting them this whole time, if I plot them, it's really absolute nonsense data. So one of the neat things about histograms is if I use a histogram, now all of a sudden I can look at the data and go, okay, yeah, this makes sense. This is a normal distribution or something along those lines.